It's me. I'm back. Amazing, right? Okay, so our last mini lecture here is going to be on ocean circulations. Um, oceans are going to actually, let's start here. I'll follow my slides. It's smart to do that. The ocean, as you would have seen in these YouTube videos, is actually really important to our climate system because it absorbs the majority of the heat coming from the sun. Okay, and compared to the rest of our Earth systems, the atmosphere only absorbs 2%, and the land mass, the continents, are only absorbing 2%, and then all of the rest of the ice absorption is very minimal, right? So we have the geosphere, the atmosphere, and the cryosphere represented here. The majority of our heat is actually being absorbed by the ocean, which is not even, I'm assuming that it's not even including uh, rivers and lakes, which also absorb some. But this makes oceans very important to our climate system. And similarly to the atmosphere, the ocean is going to be warmest along the equator, right? And this is pretty intuitive. I should have said that the last lecture too. It's intuitive, right? The tropics, it's warm, it's humid. Some people like it. I personally hate it. But the you didn't need to know that. The equator has a lot of energy, okay? And like the atmosphere, it doesn't like to be out of balance. It wants to be nice and in balance so that it can rest and be chill. And we all want to be chill. So in the oceans, it's a bit more complicated of a circulation system, but we have this conveyor belt system called the thermohaline circulation. And this conveyor belt moves all of the warm uh, ocean water at the surface uh, towards the poles. Okay. And as it reaches those polar regions, it's actually going to cool. And it's going to look something like this. Okay. So think of this as like the ocean version of a Hadley cell. Okay. It's not exactly the same, and it's, definitely not, one-to-one comparison, but it's the same kind of a process. We have the warm ocean currents being pulled from the equator towards the poles, right? And so this is kind of like a slice. Imagine like taking a slice right in the middle of the Atlantic Ocean, okay? And you have the Antarctic all the way on the right side of the screen. Left side of the screen is the Arctic. And as that ocean currents are pulling that warm surface water towards the poles, it's going to cool, right? And as it cools, it's actually one becoming denser from the fact that it's cooler water, and cooler water actually sinks, right? It's also becoming denser because as the water cools, it can't hold on to, or as it cools and becomes ice, it can't hold on to the salt in the water. So it actually starts to precipitate salt out of the sea ice. And then it becomes even more dense and more salty, and it's going to sink all the way down to the bottom of the ocean. And as it sinks all the way down to the bottom of the ocean, it's going to start to interact with that mid ocean surface circulations, and it's going to start to create mixing um, from the fact that there's cold, dense water interacting with less dense water, and then the surface currents are pulling the water away from the equator, and it's creating um, a low pressure zone. And so when it's pulling away from the equator, it wants to fill up with space. So then you get this big circulation that's very similar to the Hadley sail. Okay. Um, and again, I will preface all these things by saying I don't need you to memorize every single portion of this. I just want you to understand that the atmosphere and the ocean is circulating to redistribute heat. Okay. And these are the currents, these are the surface currents that, is these just the surface? No. Yes, these are the surface currents that actually move heat and to redistribute the heat across the globe. Okay. So there's surface currents, there's deep water currents. Let me show back. This is a combination of all the surface, and those dark purple ones are the deep ocean. And then you have these are also surface currents, and I do actually think that that bottom one is a deeper current, the Antarctic one. But things I want to point out are the Gulf Stream. That's one that we've heard of. That contributes to our hurricane season. It also makes the east coast of the United States warmer because it's pulling in that warm ocean water from the equator. And that's also what makes Europe nice and temperate, because if it wasn't, it would be a lot colder and not as fun to live in. Maybe not completely unlivable, but it definitely wouldn't be, you wouldn't be able to support life like it does now, because those warm ocean currents actually provide enough heat for that continent to actually, grow food and do things there. The West Coast has the California current. That is a cold current because it's moving from the north to the south. Okay, that's bringing cooler water against the coast, and that's why California's oceans are colder. Have you ever tried swimming in the Pacific? It's very cold. I know from experience. It's fun, but only in July. And it makes the climate there a lot cooler, a lot more Mediterranean-esque. So that's the oceans. If we put all of that together, including the atmospheric circulation, this map shows you everything put together, atmospheric and ocean circulations. Okay, we have high pressure zones, we have the ITCC, January and July, we have the ocean currents, we have the different types of climate zones, and we have different surface wind directions as well. You can see the easterlies near the equator, the westerlies in the mid latitudes. So this is kind of like the whole picture from all these many lectures put together. Okay. As I've said, I don't need you to remember all of the finer details of this, but some things that I do want you to remember. Let's start from the beginning. Weather and climate, two different things, but also interconnected. Weather is a short time scale. Climate is a long time scale, but also can be big distances, large areas, and small areas. Okay. And then you have, what was our next lecture? Oh, in the climate system, you have a bunch of Earth systems interacting to give us a nice habitable climate that we live in right now. Okay. You have different levels of the atmosphere that filter sunlight. Okay. That's a really important thing I want you to know. In the atmospheric circulation one, I want you to understand that there is a complete difference in heat being accumulated across the globe, right? There's a difference depending on where you are on the planet. The equators always receive more heat than the poles. And where the heat is directed changes with the season. So the ITCZ moves up and down, north, south, throughout the year. That gives us certain types of weather. That's why we have monsoons. That's why we have drier seasons and wetter seasons in a lot of parts of the world, is because that ITC is moving. Okay? The oceans operate much like the atmosphere. Doesn't like to have that imbalance. Okay? So it's going to create a circulation, just like the atmosphere created with the Hadley cell, the Ferrel cell, and the polar cell. The ocean has its own conveyor belt that redistributes that heat so that it gets closer to balance. And all of this being in balance with itself is what gives us a habitable planet, a habitable troposphere for all life to thrive. Okay, I think that's what I wanted you to all get from this first week. If you have any questions, please let me know. Thank you for your patience as I got these lectures out. And don't forget to do your first reflection in OneNote. Let me know if you can't find or get confused looking for that. Text me. That's why I have the Google Voice number. I may not respond right away depending on the time of day. I am a night owl, so I may help, but I may not. But if you text me, I'm definitely going to get back to you quicker than if you email me. And then, the other thing I wanted to say about the reflection, you don't need, in general, this week at least, you don't need to have this information. It's nice if you use this in your reflection. I think that's good for your learning. But I'm mostly wanting this to be a personal thing about how you see yourself and how you interact, like how you see your life interacting with our climate system and our climate, maybe the weather as a whole. It's very personal. And I don't need you to be completely scientific about this. It's okay if you're not. It's a call to reflection on purpose. It's not supposed to be a report. Does that make sense? So, great. I'm talking to you like I'm Steve from Blue's Clues. Okay. Thanks, y'all. I'll see you next